Variables declared in a function default to automatic storage. Other storage options are also available. Here I have a working copy of func.cpp from Chapter 2 of the exercise files. I'm going to go ahead and declare a variable inside of this function. And we'll go ahead and print it here using printf. And now when I build and run, you see it says I is 5. So this integer variable is in automatic storage. Storage inside a function block defaults to automatic storage. Automatic storage is stored on the stack, which is created fresh for each invocation of the function. So the value of the variable is not carried over from invocation to invocation. So if I change the value in printf again, and then run this function twice, you'll see that the second time through, the variable is 5 again, even though we assigned it 42. So each time the function is invoked, a new copy of I is allocated on the stack, and it's initialized with the value 5. And that value is not carried from one invocation of the function to another. On the other hand, I can declare this variable as a static by using the static keyword in front of int, so that's a modifier for that variable. And now when I just save this and run it, you'll notice that the second time through, the value is still 42, because static storage is not stored on the stack, and so it's persistent for the life of the entire process. So now the value is carried from one invocation to another. In fact, if I use the increment operator here, you'll notice that those increments are carried over from one invocation of the function to another. Because automatic storage is stored on the stack, it is not suitable for large objects. It's always a good idea to avoid using automatic storage for anything larger than a few scalar variables. So for example, if instead of an integer here, I was using a large object or a string or something like that, I would want to make sure that I'm using static storage for that and not automatic storage. One other important note, it used to be possible to declare a variable as auto by using the auto keyword here. And you'll notice that this raises a warning inside my code here. Auto storage class specifier is not permitted in C++11 and will not be supported in future releases. The auto keyword has actually been repurposed in C++11. It means something different, and we'll cover that later. But because automatic storage is the default, there's no reason to declare it, and in fact, it was never really even used. So variables declared in a function default to automatic storage. If you want your data to be persistent, you may declare your variables as static, and we'll cover other types of memory allocation later in the course.